I'm Samin Ali Khan, and welcome to the AI Summit here as part of London Tech Week, where Fujitsu has been showcasing cognitive technologies in action. Now, earlier on, there was a lively discussion, and it was called Harnessing the Power of Cognitive Technologies, Winning the Global Race for a Smarter Future for Business, Government and Society. Well, it certainly had us intrigued. It was a great discussion, so much so that we got the panelists to join us and to tell us a little bit more. So let me introduce you to them. And they are Rachel Mays, who is the head of the Quantum Technologies Department for Business, Energy and Industry Strategy. We also have Philip Interlura, who's the Global Business Lead Quantum Computing for HSBC. We have Dr. Keith Deere, who's the head of Centre for Cognitive and Advanced Technologies. And we have Dr. David Snelling, who's the Programme Director, Artificial Intelligence for Fujitsu. Welcome to you all. So, Rachel, if we could start with you, please. How is the UK preparing to be a quantum-ready economy? And more importantly, what policies need to be in place for that to happen?
Thank you. So, government has put science and technology at the heart of the plans for growth. So, in the innovation strategy, quantum is one of the 7 tech families where government recognises the value and the transformative potential of these technologies to drive innovation. So for quantum specifically, we are in the process of developing a quantum strategy in order to realise that potential going forwards. But we're not starting from scratch. So we've had a quantum programme for the last 8 years, and we're building on that over the next 10 years. So really, we're asking the community, so we've done an open consultation, and we're asking the community what should we be doing to build on the current programme. So within the current programme, we have the National Quantum Computing Centre, which has a Spark programme of quantum readiness. So that's working with industry to really go through the steps of readiness from awareness raising to upskilling, and finally enabling them to explore use cases. And that works within a wider programme of hubs, challenge fund activities that work with industry. So we're looking to build on that through the strategy. The strategy will be wider than the programme, and it's great to hear the announcement of the CCAT Centre today, which will be good to work with Fujitsu going forward.
So you're definitely feeling there's a readiness for this from all aspects of industry, of technology in general?
Yes, that's it.
Okay, great. Philip, talk to us about HSBC, where you are and the approach really of HSBC to quantum and why it is important.
Sure. So we are relatively early in our journey in quantum, but we've got a strategy in place and we've made some strategic investments. And ultimately what we're looking to do is unlock the power of quantum computing to drive better customer experiences and competitive advantage, right? So that's why it's important for us. And it turns out that many of the problems that we have in financial services lend themselves well to the types of problems that a quantum computer can solve. And so, it's something we think is a very important technology that we need to be part of. So in terms of how we're deploying that strategy, well, we've got 3 pillars really that underpin it. The first is around collaborations and partnerships. So we know we can't do this alone. We have to work with hardware specialists, software specialists, academia, be part of consortiums, it's only together really we're going to be able to develop the end user applications that we're trying to move towards. Partnerships also includes actually some venture investments as well. So we also look at quantum startups and we invest in them if we think there's high potential there from that venture perspective, but also from the perspective of can they help us progress our use cases as well. So that's sort of partnerships and collaborations. The second pillar is around engineering excellence, and that's about how do we develop in-house core capability around this technology. So we are making some strategic hires. We are doing some deep research around use cases, potential use cases, and we do think we need that central core team in order to start this journey on quantum exploration. And then the third pillar is more about broader organisational readiness. So what I've just mentioned there on engineering and hiring people in, that's not sustainable. So we have to also upskill the organisation. We shouldn't forget about the talent we already have in the organisation, particularly from a STEM background, and we look to upskill them, cross-skill them as well as building innovation pipelines. And actually, we focus not only just on technical talent, but also the broader organisation. We want more people to understand the basis of quantum, because that's where we get our use cases from.
And has it been exacerbated by the pandemic and by our changing needs as customers?
So I don't think the pandemic has had a direct impact on what we've been doing, because ultimately our aim is to understand and find those applications that are going to, get advantage from quantum computing. So for us, the strategy really was solidified this year, but it's something we've been working on since the end of last year, and it's great now that it's a fully fledged program, and we're really moving forwards on that use case development.
So it's being embraced wholeheartedly.
Absolutely.
Keith, the journey to CCAT has been quite intense. Tell us about the passion and the drivers for making it happen.
So I think there's a couple of things. There was a real desire to act as a wider catalyst within Fujitsu to the Anglo-Japanese relationship and to the challenges that the UK faces that Rachel was talking about in terms of how we commercialise emerging technologies faster. And we do that in a couple of ways. We do that through strategic investments, which are exciting in R&D programs, but at the kind of D end of R&D, right? The things that we can commercialise faster. So we're aiming to be a model for that commercialisation of innovation. We want to bring users, problems and data together in the way that Philip described, to co-create and solve problems together. And we think that has a couple of really exciting dimensions. So once you do that, once you get people onto, say, the CCAT campus working together, now you're both upskilling your own staff, but you're also educating experts. You're helping experts to understand how they apply their technology. So you have a whole raft of motivations, and then you have kind of external factors, like the speed of technological advance today. It's discussed so much. It's almost platitudinous to talk about it. But the thing is, if you're not continuously innovating and advancing, both in your business model, in your business processes, and in technology, you're falling further and further behind. There's no option to stop changing. So we are a catalyst internally for Fujitsu, and we're hoping to be an exemplar externally for how you commercialise research faster and faster to help the UK and democracies and our commercial industries stay ahead of the competition.
Okay. You might have already predicted I would ask you this, but I'd like an example. So sort of bring it to everyday level. What sort of things are we talking about? And perhaps you could as well, Philip, tell us, how this impacts somebody who has no idea about what's going on behind the scenes in that sense, but is aware that there are huge changes because of technology to their lives.
So I can give you sort of small examples and big examples, and I might start with the latter. So right now, AI is everywhere, but we, in the case of machine learning, we can't know why it's making the recommendations it does. It's what we talk about a black box technology. AI is not fundamentally explainable. We're investing both in the UK and Japan in explainable AI, and the aim of that is so that when you get a recommendation, you can understand where it came from and how it's coming up with it. So you might be, to make that real, you might be applying for a mortgage, for example, and you need to know why it's made the recommendation that it has, not just that it's trawled a load of data and made a recommendation. So explainable AI is one area. I think equally quantum simulation, which is something we're very good at in Japan, and Dave can give you chapter and verse on the technical side. But that's an area where I won't go through them now. But yesterday we were mapping out the kind of use cases that we might test to enable people to develop applications, so that when true quantum arrives, we've already tested out. We know kind of the implications and applications, and maybe we already have the applications and software layers needed for people to immediately start developing on it, so that we can upskill clients and customers in advance, like HSBC. So there's kind of big examples and small examples there. And if you permit me one more. Okay, so with like Fujitsu Digital Annealing, which again, Dave will give you chapter and verse on the deep tech side of annealing, which I'm not sure anyone knows it better. But annealing helps us solve combinatorial optimization problems. And that's a really fancy word for what you might think of as anything where you've got multiple different variables and you need to figure something out. So when you're trying to work out, well, okay, this train has suddenly been delayed, right? What does that mean for my journey onwards? And normally the train company's got to make some quite quick and rapid judgments about what it holds, what it allows cars to continue. It's got to figure out how it optimizes your journey. But we think with annealing, you'd be able to do that in nanoseconds, almost imperceptibly. Your whole schedule instantly rearranged to maximize the effectiveness for both passengers and for the train companies. So a more immediate and tangible use case beyond the financial sector, which Philip's much better qualified to talk about than I.
No, they're great examples. Thank you. Philip, do you want to add to any of that?
Yeah, I mean, we've been going through different potential use cases coming from different business areas within HSBC. And that's the most important thing right now, is finding those use cases that have quantum feasibility but also have customer and commercial value. So, if I sort of categorize the types of use cases, they come into 4 classes. The first is around optimization, which you've already spoken about, but that's could be around pricing optimization, or it could be about portfolio optimization. How do you choose the best performing assets with the lowest risk under some cost constraints? So those are important problems we have within financial services. The second category is around quantum machine learning. And I think a really nice use case here that sort of people really can visualize is that of transactional fraud detection. If you can train your fraud detection model slightly better with quantum computing, then it turns out you may be able to get fewer false positives, fewer false negatives. What does that mean? It means fewer losses going out of the bank, but it also means fewer false flags on genuine transactions that customers are making, which is less disruption for their journey. And so that balance is always there in terms of those sorts of machine learning fraud detection models. The third area is around simulation, and so this is where we run calculations many times, things like Monte Carlo simulations, and so there's a potential quadratic speed up in that area of things like derivative pricing. And the fourth area is cybersecurity, which is less about quantum computing, but more about the response to quantum computing. How do you build better protection on your data through post-quantum algorithms or quantum key distribution? So those give you a bit of a taste of some of the use cases we're looking at, but I think there's plenty more.
I know, and that's a whole raft of examples, isn't it? So, David, are we getting beyond the hype? And we've heard lots of examples. Is that proof enough then for leadership and for the boardroom?
Yeah, so that's always a dangerous question, particularly when you can answer it, well, yes and yes. We're still in the hype. And to deny that the hype exists would be a big mistake. But at the same time, it is time for leaders. And Rachel's already given us an example back to 2014, where the UK leadership has identified the need for starting to do this at a national scale. So looking at quantum technologies, and the UK did a very good job of starting with the technologies that were about to escape from the hype curve first, so some of the quantum communication technologies, quantum sensing, and now a new focus with the recent announcement to start focusing more on the quantum computing side. The same thing is echoed in places like HSBC, where the leadership, the boardroom this time in particular, is taking a look at what does the roadmap for my industry look like over the next 3, 5, whatever number of years, so that when we get to the point where quantum is suddenly changing the way in which compute operates, we're ready. And it's that readiness which comes in a couple of different forms. One is simply having the awareness of it at the multiple levels, enough expertise within the institution, not necessarily to do all the details, but to be a smart buyer of the technology. So bringing an institution like HSBC up to speed so that when they get to choose their quantum computer, they're not as subject as they might be if they hadn't prepared. So that kind of preparation, building inside skill sets, building ecosystems, all those things can start now and should.
Rachel, how ready are we then? We've got different organisations at different stages. So what needs to happen, and where are we now, and where I suppose do we need to be?
So you're right. I think every organisation is in a different place within their journey, and I include government in that as well. So within government, we're looking at how we can get different departments more familiar, aware of the potential applications for quantum computing. So I think as part of the work with the computing centre, it's really taking different sectors on that journey. And I think some sectors are further in the journey than others, but even within sectors there's a real mix. So sorry, that's a bit of a fudged answer.
Who's lagging behind then?
Who's lagging behind? Yeah. Gosh, I think probably the best way to think about it is there are some sectors where the applications are more obvious. So for existing sectors that have difficult compute problems like finance, like pharma, like the chemical industry. So I think there are some industries that really need to be taking note now and looking at that journey, and I think others will be further down the line. That's probably a better way of looking at it.
Can I come in on the hype question? So, I mean, look, when I joined the company, I said, look, looking around Fujitsu, I think we have the inverse of what many large corporations have. Instead of having a say-do gap, we have a do-say gap. As a Japanese company, we're not always as good at pointing out all the incredible things we do. I'm like, hey, we seem to have the world's fastest supercomputer. Why aren't we talking about it? Which was true at the time. There are a number of things, and Dave was teasing me sort of X months in, saying you're in danger of closing that do-say gap on your own. And I'm not sure it was completely a compliment. But I think look, you do sometimes need to think, well, how do we get beyond the hype? Because we obviously have an incentive to talk up the technology. Yeah. And one way you do that is for looking to independent authorities. So I might be the living embodiment of the attempt to close the do-say gap, yep. But we have Ellen Devereux who works for and with Dave, and she's kind of the embodiment of so much that we want to achieve through the CCAT. She's doing a PhD in quantum computing. We hope we're going to create 200 jobs, high-skilled jobs through the CCAT, and I hope there will be many more Ellens through that program. But I mean, also Ellen's just written a blog post for us that bounces off of a Nature article. So Nature is the leading journal in science, independently evaluating annealing technologies, and the Fujitsu digital annealer comes out top in one of the key for MP hard problems. Is that right?
That's correct.
And Ellen goes on to explain exactly what that means, and also to say that this was competing with true quantum, where ours is a digital annealer. People said, why do you want a digital annealer? Well, you want it because it can be in-house, it can be off-network, it doesn't have to be cloud-based, and you want it because it outperforms the competition, and it outperformed the competition in that category, despite being the 2018 version, when the current version is 92% faster and more effective. So that's me closing the do-say gap by pointing out something we have done.
Actually done, yes, absolutely.
I'll be honest, you lost me at the NP hard, so what's that? What is that, Dave?
NP hard is a class of problems that is so hard to solve that we are not entirely sure that there exist solutions today on existing technology. It's just the computational challenges explode so fast, and then there's a very subtle difference as to whether NP hard is equal to NP complete, but we won't go into that. These are just really hard problems to solve that really quantum computing is our only hope, if you will, and that's what we're looking for. That's why we're pushing it. That's why quantum is on the agenda for so long.
And I think I'm going to say it with you. Like, the key thing is we're doing it now. Right? That's the key thing. Yeah.
Okay, so fingers crossed you are future-proofing.
Future-proofing. Well, yes, as Keith says, we're doing it now. So with the quantum annealing and quantum and digital annealing technology, we're doing that today at production level. But it's all stuff that can be used when quantum goes to its heyday. Yeah. So we can actually solve problems today using quantum algorithms and techniques on digital technology that's reliable and trustworthy. That's future-proof, because when the quantum computers come, those algorithms will be the same, just faster.
Right. Okay. So, Philip, back to the boardroom then. And in terms of them actually preparing and identifying quantum and how it can add business value and indeed grow that trust, where are the boardrooms?
Well, I think that the boardrooms are bought into it because you don't get a sponsored and strategic program, which is an important part of our digital innovation agenda, unless you have that sponsorship. So I think when it comes to programs like this in such nascent technologies, having that board level sponsorship and that governance around it is really important. So we have that. I'm proud that we have that, and we're progressing now this agenda. The use case development's really the next important thing that we focus our attention on. And I think, like Dave was saying, I think it's not necessarily all about that holy grail application on a universal gate-based quantum computer. That is some years away. There are a number of technological milestones we need to overcome before we will see fault tolerance. But if you can start to build a portfolio of use cases which maybe look at annealing technology, inspired technologies, particularly for optimization use cases that I've mentioned, then actually you might be able to find some nearer term applications as well. And I think that also goes for cyber, QKD, and those sorts of things. They're more mature. So it's a pretty exciting time right now in quantum computing. Yeah,
I can see that from the just from the expressions on your faces when you're talking about it. CCAT then, Keith. I know you've mentioned it already. You've spoken a little bit about the job creation and certainly about the impact that will have. Where do you see it actually ending up, or where do you see the impact sort of a year from now, for instance?
Well, I think in 12 months we will be aiming for further announcements on some of the programs that we've invested in, some of the partners that we're working with. Those discussions are all ongoing, and as we pull the team together sort of full time following this announcement to really drive it forward, you'll see an awful lot more. We've got some vanguard projects that we're already working on. I mentioned University of Manchester for explainable AI. We have some other projects working with the National Digital Twin Programme that I've spoken about a couple of times today. So I think in 12 months' time you'll see an expansion of some of those vanguard projects, the establishment of some of those projects and programs around co-creating around users, problems and data, and hopefully the advancement of some of those grand strategic projects that I talked about, where collaborations between the UK and Japan and us acting as an innovation bridge, both to share data between countries and enable our small medium enterprises in the UK to access Japan's markets, and reciprocally their cutting edge SMEs to access ours, so that we're all learning and upskilling together.
Now, we know that this sort of information, this sort of technology is going to release what is termed as never seen before business value, or added value, I suppose, in some respects. If I am a CEO, I'm probably interested in this, I'm very excited, I'm thinking I want to know about this, I want to know how it's going to impact my industry. So what should CEOs be doing now?
Well,
David?
one of the things they need to do is step back and take a look. So just to start with a little example, very simple one, warehouse optimization, where we got people walk around warehouses putting together orders for your deliveries, industry explosion during the pandemic. And yet, when we went into some of our potential clients there and clients in the warehouse industry, we were getting between 15 and 30% improvement in the pick rates by trying to solve problems that were relatively straightforward for our technology, okay? And the real problem was not looking for the problems that need solving. They were worried about other things. And so taking a step back is one of the things.
What do you
well, in this particular case, the things they were worrying about were customer-facing things, shinier web pages and things like that, and not thinking about how many steps is someone actually taking to put the boxes together and that's the one that gives an impact onto I forget the finance, wherever the costs come from, top, bottom line, something like that. So the idea is that those kinds of places are where the big benefits to the corporation come from. And that, of course, then releases more capital to do the fun stuff up front and make the user interfaces better. So what corporations need to do is to take a step back, look at what the technology could do within their own enterprise. Now, the work we've been doing with HSBC around a quantum value assessment is to do just that, to take a look at the various different parts of the business from an external point of view. Helps a whole lot to say, okay, well, we're going to ask all the kinds of questions that, first of all, are the dumb questions, because we come in as technologists, not as banking specialists, for example, and ask the kinds of questions that, oh yeah, okay, why do we do it that way? What else could we do? And that kind of opens up the possibilities, not just with quantum in the future or quantum annealing now, but with just normal data analytics. It says, oh, we could do that. And so the possibilities of this kind of engagement are more than just planning for the future. They can actually help you today.
Okay. Rachel, do you want to add what you think CEOs should be doing at this stage, given where we are?
Very good question. I think all the things it's planning to do are the right things, and so I think from a government perspective, we're looking to work with industry to try and bring users into the conversation and start to go through the journey. So and I think it is about saying quantum is one of your many tools. So I think that's a really useful model for that approach, where you're not sort of selling quantum, if you like. You're looking at what is the best solution, one of which might be quantum, and actually by doing that you're getting people, you're upskilling people to be ready when it is here in the future. So yeah, I think it's doing all the things that government would want it to be doing, I would say.
And Philip, I know it's a competitive industry.
Oh, well, what can I say?
Well.
So, I would just say that I think quantum computing is such a potentially game-changing opportunity that the least boardrooms can be doing is talking about it. Yeah. And I think it's really, it really is a sensible thing to do to start talking about the use cases that might exist in that organization that could benefit quantum computing. And if it turns out that those things could significantly impact your competitive advantage, your customer experiences, then take a strategic view around that. Be deliberate in your investments. David said there's a lot of hype. There is a lot of hype. We shouldn't lose the fact that we are many years away from fault-tolerant quantum computers, but you could be strategic in what you invest in today to just start exploring some of those potential revolutionary sort of changes that can be made to the business model.
Yeah. So it sounds like at least have the conversation.
At least have the conversation.
Okay. Panelists, thank you all for joining us. It's been fascinating talking to you, and thank you very much for your time. And that is just a fraction of what is actually available from Fujitsu in this rapidly changing world. Now, if you want more information, you will see a link appear on screen as if by magic very soon. And of course, if you have any questions that you want to put to any of our panelists, get in touch and we will put you in contact with them. For now, though, thank you for listening, and I hope you enjoyed this conversation.